Okay, so why don't we go ahead and get started today? Um, so today we are basically going to be continuing with the SD card activities that we started on Tuesday. So on Tuesday we did some pretty basic and somewhat cheesy examples of just how to interface with the SD card. Um, Basic writing text. And today we're actually going to do some more realistic examples. We're going to create multiple files. We're going to have um, some fake data. We're going to make a CSV. We are going to make it so that when we lose power to our Arduino, we resume on a new file. And we are also going to interface with the GPS and write some of that data to the SD card. So you can see here on the camera, I've got my Arduino all set up. I've got, the jumpers on this particular one are a bit messy, but it's fine, they work. So here's my GPS hooked into serial 1. And I've got my SD card with my adapter handy. So just a general tip I find that works well when you're doing these SD card activities. I usually will, obviously you need to plug the programming cable in. So I'll go ahead and do that. But when I upload my code, I usually upload my code before I insert my SD card. So, and as you saw from our examples last time, I'll usually have a little error catch in my setup. So the code will upload and then it'll basically not see the SD card and pause in the setup there. And I usually do that so that I don't basically just write a ton of unnecessary data to the SD card that I may not be interested in. So after I upload the code, I will then install the SD card. And then hit the reset button, which will restart the code from the beginning. And in general, that's going to get you that'll start it off with the SD card, and that way you can watch the data writes and everything sort of from the beginning. Okay, so like I said, all that we're doing today is we are continuing with our programming activities, and we're going to do some more advanced file writes. In particular, we're going to create an actual CSV of it's just some dummy data that's variables that we are going to install or declare within the program itself. But it would be very easy to modify that as to use real data that you've read in with, like the read analog, for example. And then after that, we are going to make it a bit more realistic. So we're going to actually make multiple data record files, and we're going to go over how to basically resume writing data from where you left off. And then the final thing that we're going to do is we're going to actually use the GPS we're going to record some NEMA data to the SD card. So the very first thing that we want to do, though, is we're going to work on creating a CSV file. So like we said during the lecture, the advantage of a CSV file is I can open it up directly in Excel. So and it's a plain text file that is easily read in by a bunch of different types of data analysis software. So the first thing that I want to do is we need to do all of our basic declarations, right? We are going to have all of our pins defined, but then I'm also going to define, my file object. And this is all in the global variables before your setup. Obviously, you need to include your libraries. This is meant to continue on, and you should actually be able to somewhat modify the code that you were working on last time. And then I'm going to create a file name here, right? What I'm going to use as sort of as my simulated data is I'm going to create an array of floats, and I'm going to give them these initial values of 1.5, 3.25, 5, and 7.57. But I mean, honestly, there's no reason you should feel the need to use those particular values. Those are just numbers that were picked. So after I declare all of my globals for my SD interface, I'm going to declare my array, right? So this is a float type. I give it its name, and then in brackets, I'll put 4, indicating that this is an array of 4 entries, and then I put the actual entries like this in a brace. So next, so this is written somewhat assuming that you were working on continuing from the previous code. So we're going to modify our setup. So we're going to have the initialization of the serial port and the SD card like we did before. Then we are going to open the file, but previously in the very last activity, we had been doing our writing in the setup and there was nothing in the loop. So all that we're going to do in the setup here is actually open the file. In the loop, we need to actually do a few different things. We need to reopen the SD card to write. We need to write the 4 values that we're going to use. We're going to then close the SD card, and then we're going to add 0.5 to all those numbers just to increment them so that we can see that the data is changing. And then we're just going to put in a short pause, and we're going to have some debugging statements there. So if you look at the code, let me share my full screen. Okay. And let me zoom this in a bit. All right, so like we said, we have to have all of our include statements that we covered last time for our libraries. And again, we went over this in detail last Tuesday, but you really need to, you have to manually install the particular SD card library that we're using. We declare all of our PIN numbers, our file object, and our name and our float. We do all of our setup, as we just said. And now this is our loop where we're actually doing the majority of the work. So obviously, like we said, the very first thing that we need to do is just open the file. So again, we use that sd.open function. But we're going to do a bit of an error trap here. So remember that this function is going to return a value, and if it fails to open the file for whatever reason, it will skip over this entire if statement, so we don't try and write to a file that was not successfully opened, and we'll get a little error message. How we're actually going to do the write is we're going to use a for loop, right? So we have 4 elements in our data array. So we're going to make a for loop that steps over those 4 elements. So it's been a while since we covered the looping stuff, but you declare the for loop like this. You give it basically the variable that you are using to control. You give it the exit condition, and you give it the incrementing step that should happen on the completion of every loop. So this is going to start at I equals 4. It'll do I equals 0, or it'll start at I equals 0 and go until I equals 4. So it'll go I equals 0, 1, 2, and 3. And that will, and each time it's going to print out to the file the element of the array. So that's going to be each of my numbers. My 0 will be the first number, because arrays in C++ are 0 indexed. That means you start counting with the first element being 0, second element being 1, 2, 3, etc. So I'll print out the number, I'll print out a comma, and then I'll go back to the top of the loop. I will increase I by 1, and now I'll go back through that. So this is going to print out my 4 numbers in my array, each time followed by a comma. So this is also going to have a comma after that last number, which is fine. That's not going to mess up our file at all. Then the last thing I'm going to do is I'm going to print line with this empty string. So this isn't a space or any particular character. There's no character between the quotes. And I'm just using that because this is going to add the new line. So that means the next time when I print data to the file, it will be on a brand new line. And then I'll use that. Excuse me. I will use the flush function to make sure that write actually happens right now before I proceed. This else statement here is just part of this if statement, which will basically print out an error message to the serial port if for some reason I did not successfully open the file. And then I'm going to close the file, print done. So, and then I'll use a second for loop that will actually step through the array and add 0.5 to it. So, and then I'll just wait for 3 seconds before I get to the top. So what I should see when I open the file is I should see four columns and numbers, starting with my initial values that I've declared up here. And then it should count up by 0.5 in a new row. And it's just going to keep doing that. So first, let me go ahead and upload this code. And if I open my serial monitor, I'm just going to get the failed to initialize message, which is fine. I haven't put the SD card in yet, so I sort of expect that. So now, when I install the SD card, let me just clear my output so we don't have to worry about the old thing. I'll hit the reset button here, and all that does is restart the Arduino. So it's going to run the code that I just uploaded when it restarts. Okay. And so you may see this sometimes, this double line. So sorry, that is because one of those is from my setup and one of those is from my actual loop. So if I go here, basically every time it writes, I'm going to get one of these open successful and a done. So if I let this go for a bit and then I unplug the Arduino and then I look at the data on the SD card, sorry, give me 1 second. Having a little bit of trouble. Okay. So when I look at my SD card, I've got the one file here, single file, and I can either open it in a editor, a plain text editor like Notepad, and you can see here, I've got my initial values. I've got 4 sets of numbers, and this is counting up by 0.5. So one thing you'll notice on my SD card here, this is actually defaulting to open in Excel, because if you have Excel or I think other spreadsheet software, they will associate CSVs with themselves. So you should be able to just open it directly. And as you can see here, this will open up in a spreadsheet. And I have all of my values. They are separated into commas. And yeah, so you see there's this message here. So this is some features may be lost, right? And that's because this is a CSV, so it's a plain text file. So it can't, if I type in like formulas and have them calculate, and I have this save as a CSV, what it'll do when it writes the file is it'll just write the result of the formula, but it won't keep the formula, because that's not something you can actually do in the CSV. But I can easily save this as an actual Excel spreadsheet and then do the full thing, full graphs and all of that sort of thing. It's just in an actual CSV, because it's a plain text format, you can't do like formulas, graphs, graphics, all of that stuff. So also you want to look here is Excel has basically rounded off, dropped my trailing zeros. So if you look at the actual values here, for example, this is 5.00 and 1.50, whereas in Excel, it's just, drop those trailing zeros. So one thing you will notice though, is that all of these values are rounded to 2 decimal places. And that's actually part of the print function. So when you give a float, you put a float in this print function, it will default to 2 decimal places. However, I can control that. So if I want more decimal places or less, I can basically put a comma and tell it the number of decimal places. So if I put like a comma 4 here, it's now going to record all of those numbers to 4 decimal places. The other thing that I don't have here is you can see it just starts with the numbers. And one thing that you want to do usually is write a header to the first line of your data file so that when you open it up, it's easy to keep track of which number is which. So I can easily do that. I just need to add that line like this. So if I go to where in my setup, where I first open the file, I'm going to have it print this series of numbers. So I'm just calling these number 1, number 2, number 3, number 4. And then I'm matching it with the commas, just like I did my other entries. Obviously, if these were real numbers, I'd probably want to put like temperature or altitude or whatever the actual label is for those numbers. I might want to include units too. So now if I've made these 2 modifications, I've changed the number of decimal places, and I've added this header. So if I upload that code to my Arduino now, oh, sorry, I still have my serial monitor open. So that was blocking the upload. And I'm gonna install the SD card. Importantly, I'm purposely not going to erase the data when I do this, because I want you guys to see what happens. Right, initialization failed. So now let me go ahead. Install the SD card and restart it. Also, one other thing you can notice, let me blow up the camera. You can see this L13 is blinking every 3 seconds. That is actually blinking when I am doing the writes to the SD card. So that LED is a good way to troubleshoot and make sure you're actually sending the signal to the SD card, because if that is not going off, that means you're not, that's actually hooked onto the SPI clock pin here. So when you're sending a signal, that is going to flash. So because it's flashing so quickly, you know, I just see it basically briefly blink when it does that read. So now let me eject my SD card and take a look at my data. So remember, I did not erase the old data. So I still had the test CSV in there. So you can see, one, I didn't get a new file, right? It didn't automatically, it wrote to the file that I told it to. And something's gone wrong, sorry. Because I did not, oh, there we go. I think it just, so you can see here, this is my old data from before I restarted and re-uploaded the code. So this is the new data that actually ran. And this is an important thing to note, is when I use that write and I open an existing file, it's just gonna append it to the end. And this can be important because if I'm using a bunch of different data files and now I lose power and I restart, the way this is written now, it would go back to the very first file and then just add the data there, which is probably not something that I want. But you can see here that it did add my data headers, and I've got a nice column label. So if I in fact did delete the data, and let me just do that real quick. Now I put the SD card in. And I restart it. And I let that run for a little bit. and I open my data, hey, I've got my column entries at the very top followed by numbers. So another thing, another quick example I can show you is what is going to happen with this code if I get a bunch of like restarts. Let me restart it. Open up my serial monitor. Right, so I've got one data packet, two data packets. Hey, let me hit reset a couple of times. And let me just reset again without erasing or deleting the data. So now if I take a look at that data, I'm going to have a whole bunch of restarts. So since I've been writing this all to one file, this is how it looks. And this is really most likely not how I want to have this work. I would probably want it to create a new file every single time that it restarted. Also, you are probably not going to want to have one giant data file. In general, it's a good idea to basically break it up and maybe have your data create a new file like every 5 minutes or every 10 minutes or at some regular value, because that way, if something happens to one of those data files, if it gets corrupted for whatever reason, you don't lose all of your flight data. So for the next section, we're going to show how to do that. So first, let me just delete my SD card. All right. So the next thing that we want to do is we're going to want to basically write data into multiple files. We're going to give these files a more meaningful name other than just test. So in this case, we're just going to sequentially number them. So we're going to start with DR0, and we're going to count up from there. So we'll have DR0, DR1, DR2, DR3, etc. We're going to use the same sort of fake data to just because we don't want to have to worry about some sort of sensing circuit at this point. We're just trying to do SD cards. We're also going to limit it to 10 records in each of our files. So after we write 10 data records, we're going to skip to the next file. And the way that we're going to do this is we're going to basically write a function. We haven't really used the ability to write our own functions before. We sort of have with the interrupt, but that's it. But in general, when you have a task that you're going to do repeatedly, or it's like a well-defined task, it's a good idea to break it into a function so that whenever you want to do that, you just have to call that function, and it also organizes your code a little bit better. So we're going to create two different functions here. One that is going to create our new file, and one that is going to actually do the writing of our data to the file. Also, one thing that we're going to do with the way that we're going to write this new file function is we're going to make it so that when the Arduino gets reset, it's going to check for all the existing data files, and it's going to find the first unused number, and then it'll start writing data to that. So because of that, we're going to need a couple of additional global variables. So we still need our file name, but we're going to change it. Like I said, the initial file name is going to be DR0. We are also going to use a string variable. So there's a few different ways you can actually have multiple characters in a string, one of which is the actual string type, and one of which is an array of characters. So this is just like our float array, except it's an array of chars, right? So file name 0 would be D, file name 1 would be R, etc. The SD card library wants a character array for the file name. That's just how it's written. It needs a character array as its file name. But the string type, it's easier to combine multiple strings together into a single string using the string type. It's a little bit easier to manipulate using this. So we're going to use this temporary string variable to basically create our new file name every time we make a new file. And then we're also going to need a number that's going to be tracking our file number, right? So this is going to start at 0 when we're on DR0. It's going to go to 1 when we get to DR1, etc. DR2, that will be 2. We're going to have the same test data, so those 4 same numbers. However, we are going to add 2 additional pieces of data. So remember, we want to be able to uniquely identify each of our data packets, right? So we're going to add the file number as the first column of data, and we're going to add the ID, which is just going to be the count of, hey, this was the first data entry in the file, this was the second data entry in the file, etc. So we're going to add those to our header, and when we write our data, we're also going to write those 2 values. Another couple of variables that we need a variable that will be the, I've called it max writes here. This is just the number of data records in an individual file, i.e. after we have 10 writes to that file, it will go on to the next file. And we need another variable where we're going to track that. And like I said, we're going to need these 2 functions. So our setup is really even simpler than it was before. We have our serial port initialization. We have our SD card initialization. But rather than opening the file, we're just going to call our function, right? Because we've decided we're going to write a function that's going to open a new file. And since we know we want to open a new file when we first start up, we'll call it here. The loop is also going to be very simple. So we've moved all the data writing into that function. So all we need to do is first check, hey, have we written the max number of data records that we want to a file? If we have, create a new file. And then we know we're going to write data. And then we just want to add a pause again, so that this doesn't immediately loop super fast and I don't get like 50 files in like 2 seconds. The tricky part is going to be those actual 2 functions, the function that writes the data and the function that creates the new files. The data writing function is not too hard. It's fairly similar to what we had in our previous loop function, right? So we're going to open the file. Before we actually print out the data, remember we added 2 additional pieces of data. We're going to write the file number and then a comma, and then the data record number or the number of writes and then a comma. Then we're going to use the same for loop to print out the numbers. I'll start my new line, I'll flush it, and I'll close the file. And then I will increment all of my values in my data array. And then I will also need to increment the number of writes that I've done to the file, right? Because I want to keep track of that now, because that's how I'm going to determine when I need to start a new file and match the data number in that individual file. The trickier bit is going to be the new file function. So the first thing that we want it to do is we want it to open a new file, but we want to make this work so that it's going to check and see if the file that we're trying to open is one that already exists. And if it does, go to the next number. So the way that this works, there is a function, SD exists. And what that'll do is if whatever I give it in the file name here, it will return true if that file already exists on the SD card. If it does not, it will return false, and it will skip over this entire loop. So when the function first starts up, it's going to first try DR0 because that was the default file number. If it's the first time I'm writing data to the SD card, that file doesn't exist. So it is going to skip over this part, and it's going to go to the part that actually opens up the file. If I have already written to the data, data to the SD card, or this is at the end of my file where I'm now moving on to the next file, this will be true. So it's going to go into the loop. So it's going to print out the file name so that I know the one that it just tried. It's going to increment the file number by 1. So it's going to take 0 to 1, 1 to 2, etc. Right? This is the number that I'm actually tracking what number file I'm on. Then it's going to combine, it's going to make a string out of that DR prefix, the string. So it's going to take the file number that I've just incremented and turn it into a string instead of a number. And then it's going to add this .csv. So this is going to now be a string that is dr1.csv or dr2.csv. Then it's actually, this is the line that actually copies the string here to that character array file name, which is what I actually need to give it the SD card library, remember? And then I get a little debug message that says, hey, the old file name already exists. I'm trying this new file name. Now it goes back to the top of the loop and checks that again. So if that file doesn't exist, it will go ahead and create the file. If that file does not exist, it will proceed on and create the file. If it does exist, well, now it's going to increment it again and try again. So it's just going to keep incrementing until it finds the file number that hasn't been used yet. Once it does that, I'm going to open that file, which will create the file, tell me that it's created. It will print that file header and then close the file and now return. So the way this works is, one, it's going to create a new file every 10 data points. But this is also, after a restart, going to go ahead and go back and check through all the existing files until I get a new one. So that will mean after I restart, I don't go back to DR0 and add data onto the bottom of it. I will get to the end and add it there. So once again, let me upload my code. a serial monitor, once again, I will get a failed initialization. So if I install my SD card, restart. So first thing, boom, initialization successful. It created DR0. It did a bunch of writes, and now it goes to create a new file, and it sees DR0 already exists. It goes on to the next one. So this is how it's going to operate normally. So each one of these files, when I open it up, should have 10 entries in it. Let me let this create a few different files. So I'll let it get up to like 5 or something. Now I'm going to restart. So you can see on the restart, first thing that it did, it tried to make DR0, 1, 2. It basically saw that all of those files existed, and it kept trying new files until it got to the new one that doesn't exist. So that resumes at the end of the data. So if I take a look at this, and this is something that's really important for your actual payload. You want this sort of behavior. Otherwise, your data is going to be all mixed up. So you can see each one of these has 10 entries. Actually, I think I did 11 entries just because of how I set up the loop. I've got my file number and my ID. I go 0 through 10. Boom. I have it incrementing. Each one of these is like that. I don't go back and add data to an old file, which is very important. It keeps my data nice and organized. In fact, I can go ahead install my SD card and restart, and it's going to pick up it right where it was with 11. The last file that had been on there before was 10. And every time that I restart, it's always going to go through and check. So one thing that the way this is written is if I get a restart in the middle of a file write, I'll have one file that has less entries, but that's probably a good thing. It lets me see where the restart occurred. I'm not mixing in. I always have one header at the very top. And then the last part of the activity that you guys are going to do is basically we're going to implement the GPS as well. So what you want this to do is you're going to set up the GPS to only output RMC sentences. It didn't necessarily need to be RMC. We just wanted it to do a single sentence, and we set it to 1 hertz. We're going to have it record the NEMA sentence every time it receives that. We're going to you want it to do a similar sort of thing where you're using numbered file numbers, so GPS 0, GPS 1, GPS 2, GPS 3, etc. And you want to basically have it do the same behavior as it had before. And again, we're going to want a header. So you want to look at the RMC definition and figure out what pieces of what the individual pieces are in the RMC data. Now, the advantage is the NEMA sentences are already comma delineated, so it has the format that I want. So if I upload the GPS code, now this one, we're not going to go through step by step like we did. You guys should try and figure it out from the previous examples. But if I upload that code, and I restart, I think I uploaded the wrong code because it was doing DRs. Oh, yeah. I had the serial monitor open, so it didn't actually upload the GPS code. And I'm going to go ahead and delete my old data. Restart. So you're going to see that because I'm only writing every time I get a new NEMA sentence, that's why I'm only writing once a second, and this count is incrementing once a second. And the way that this is set up, it's going to redo the file every 10, or sorry, every 20. So if I go ahead and look at this data, the way that you want this outputting at the end. First, if I look at this in just the raw text output, you can see that I've added this header line at the beginning. That lets me know what is in each section of the RMC sentence. The first couple of sentences you're going to see are actually the acknowledged sentences that you got for your setup commands. So that's what these first two are, but they are going to get returned when I call last NEMA. So that's why these get written. Then the actual RMC sentences start up. And you can see these are just the raw RMC sentences. Notably, right now, if you look at my LED, my fix LED, it's not blinking, or it's blinking once a second. That's because I do not currently have a fix. So the first data record, and this is, again, if I open that file up in Excel, it will actually organize this a little bit better. So the first thing that I'm going to get is a timestamp in this format: hours, minutes, seconds, and then tenths of a second, or milliseconds as a decimal. If you don't currently have a fix, this is the time that you're going to see it start. It's going to start a little bit before midnight. So you can see this is 23 hours, 59 minutes, and 45 seconds. And the date will be this format. So day, day, month, month, year, year. So Excel has dropped the leading zero off of this, but this is actually a 05. So it's the 5th of January, 1980. And that's just because that is the default time that the GPS is going to start at when it doesn't have a fix. And you can see basically here is right before midnight. And then right after that, that increments over, and Excel has dropped all the leading zeros here. But you can see that the day has switched from the 5th to the 6th. So that's the rollover at midnight. And if I eventually would get a fix here, but I still have not, so I can't show you that would update to the current time and date. Well, it would be the GMT time and date, so not Central Daylight Time, which we're at. It'll be GMT, so I believe that's 5 hours ahead of us currently. It's either 4 or 5 hours ahead, depending on daylight savings. I don't remember which way it switches. Okay, so that's what you guys should work on today. Try and get all 3 of those activities done. Make sure that you can get that file resume thing working. That's going to be very important for your actual realistic payloads. So that is it for today, guys. Just work on that. Let me know if you have any questions.